Hello, and welcome to the Federal Railroad Administration's Rail Program Delivery video series. I'm Anthony Thomas, and I'm pleased to introduce Ryan Bash, a planner with the Passenger Rail Policy Division at FRA.
Hello, everyone.
In this video, we'll go over the elements that make up FRA's Benefit Cost Analysis Guidance. FRA's guidance on how to conduct a benefit cost analysis for FRA-funded or financed projects is in accordance with DOT's Benefit Cost Analysis Guidance.
A benefit cost analysis, or BCA, is a systematic process for estimating and comparing the benefits of a project to the costs of the project over a specific period.
BCAs help decision makers organize information about and evaluate trade-offs among alternative transportation investments. FRA expects to receive BCAs that are consistent with the methodology outlined in FRA's BCA guidance as part of the justification for seeking federal funding or financing.
FRA recommends that you undertake a BCA when commencing project development. FRA also requires a BCA as part of many grant programs, although specific requirements will be provided in a federal program's Notice of Funding opportunity.
Let's begin by going over some of the key elements that comprise a benefit cost analysis. To develop a BCA, you should quantify and/or monetize all potential benefits and costs of a project. If you are unable to monetize certain benefits or costs, you should attempt to quantify them. If you are unable to quantify a benefit or cost, you should describe it qualitatively.
Money has a time value associated with it. As such, benefits and costs that occur sooner in time are more highly valued than those that occur in the more distant future. This principle is called discounting. BCAs use discounting to account for costs and benefits that occur at different points in time. This allows for benefits and costs to be expressed in a common unit called present value, regardless of when they are incurred or received. Details on how to calculate present value can be found in Section 3.1 of FRA's BCA guidance. Additional information can be found in the Office of Management and Budget Circular A94.
Due to inflation, the same amount of money will buy fewer goods as the years go by. When doing a BCA, if you don't account for the effects of inflation, your analysis will be in nominal dollars. A real dollar is a hypothetical dollar that has been adjusted for inflation. In BCAs, a real dollar has the same buying power from one year to the next. BCAs can be done in either real or nominal dollars, as long as you are consistent, but FRA recommends using real dollars.
Another fundamental element of BCAs is the analysis period. The analysis period is the time over which the costs of your project are incurred and the benefits of your project are accrued. Many projects involve large capital expenditures up front, but their resulting benefits may not be fully realized for many years. To capture this dynamic, the analysis period should encompass the full construction period and an additional operating period during which the benefits and any recurring costs are realized. FRA recommends that your analysis period include a minimum of 20 years after construction completion.
Your analysis period should capture the useful life of the project. However, in a BCA, each subsequent year is discounted more heavily than the previous year, and thus, each subsequent year is increasingly unlikely to impact the overall findings of the analysis. For these reasons, FRA recommends that you generally avoid analysis periods extending beyond 40 years of full operation.
Each BCA needs a well-defined baseline to be measured against. A baseline is sometimes referred to as the do-nothing or base case, or the scenario in which you merely maintain current conditions. For example, a baseline should reflect the economic and population growth and could include projected passenger traffic or freight shipping flows, regardless of the project being built. For more information on baselines, refer to Section 3.5 of FRA's BCA guidance and the documents listed on your screen.
A thorough BCA should include several alternative projects other than the one being proposed. A good candidate for an alternative project would be one that accomplishes the same goals as your project, but goes about it in a different way. Contrasting your project against several alternative projects helps illustrate that your project is the most effective way to accomplish the goals you intend to achieve. For example, other alternatives may meet the same project goals, but may have fewer anticipated benefits or greater costs.
All BCAs should be both transparent and reproducible. A transparent BCA is one in which all of the assumptions, inputs, and outputs are clearly outlined and documented. Reproducible means that a qualified analyst, using only the assumptions included in your BCA, would come to the same result. Transparency and reproducibility lend credibility to your analysis.
Here's a helpful hint. It is important to know the difference between economic benefits and economic impacts. A BCA measures both the benefits and costs of the project to society. An economic impact analysis, on the other hand, measures the impact of increased economic activity within a region. In other words, an economic impact analysis only measures the positive effects, such as increased jobs and increased spending. Now that we've covered the key component parts, let's go over the B in BCA, the benefits that result from your project.
A benefit is the positive outcome that is expected as a direct result of your project. Benefits can be experienced by the users of the transportation system, such as increased level of service, or the general public, such as reductions in traffic congestion and emissions.
Benefits should be monetized and recorded on an annual basis throughout the analysis period. Some benefits may be difficult to monetize, but let's take a look at some common benefits and how to monetize them. We'll start with the most common type of rail benefits, those that directly impact the current and future users of a rail system. These generally include increases in ridership and freight flows, reduced travel time for passengers and freight, and increased reliability. We'll also cover benefits that affect the community as a whole, such as safety benefits and environmental benefits.
The amount that users benefit and the type of users who benefit depends on the service improvements that a project creates. Some additional examples of passenger service improvements include improved stations and enhanced passenger amenities, such as ride comfort, accessibility, food and beverage offerings, and internet availability. Additional freight service improvements include more efficient intermodal connections and decreased terminal dwell times.
Estimating increased demand from the improved service can be difficult. There are a number of sources that can help you figure this out.
First, you may be able to estimate ridership increases based on your past experiences in changing fares, trip times, and other factors. You may also be able to use market data, such as rider surveys.
In terms of freight rail, freight operators may be able to share their data. Usually they'll have market data showing changes in demand associated with changes in freight rates and delivery times. You may also need to use travel demand models and traffic simulation models to better understand the freight flow impacts of your project.
Two benefits that users of the rail system may experience are reduced travel time and increased reliability. For both passenger and freight railroad operators, increased reliability may help them use their fleets more efficiently, which reduces the need for additional equipment. For passengers, increased reliability reduces wait times and makes taking the train more predictable. For freight, increased reliability may decrease the cost of shipments and help streamline supply chains. Quantifying the reliability of rail service in a BCA can be challenging, but quantifying and monetizing the reduced travel time is relatively straightforward. FRA recommends you use the Department of Transportation's Value of Travel Time Savings, as well as Section 5.1 of FRA's BCA guidance to help calculate these.
Due to an increase in reliability, you may achieve reductions in cost to either passenger or freight systems. If you have sufficient data on these reductions, you should include it as a benefit in your BCA. However, it can be difficult to obtain accurate data to determine the precise reductions in cost. You should acknowledge in the BCA that accurate data is difficult to assemble. If you do not have sufficient data to monetize, FRA recommends describing the benefit gained from reliability qualitatively.
Safety benefits can be included in a BCA when a proposed project will reduce the likelihood of a derailment or other type of incident. To claim that a project will result in safety improvements, you need to clearly demonstrate how a proposed project targets and improves safety. This is done by establishing crash causation factors and drawing a direct link to how the project will mitigate those factors. Some examples of project elements that would increase safety are improvements to grade crossings, shifts from alternative modes that involve higher safety risks, and improvements in rail infrastructure or technology that reduce crash risk. For an example of monetizing the value of safety improvements, you should refer to Section 5.2 of FRA's BCA guidance.
Environmental benefits are a good example of a type of benefit that does not directly affect the passengers on the railroad. You'll typically measure the expected emissions changes and monetize them using the values for the social cost of carbon and the criteria pollutants.
Emissions from transportation are considered an externality. While there is an environmental cost to the emissions, neither the users nor the operators pay the cost directly. Society as a whole pays the cost of increased emissions.
Rail projects can bring the benefit of fewer emissions. Generally speaking, traveling by rail results in fewer emissions per passenger mile. This also holds true when freight is diverted off the highways. To show that a potential railroad project reduces emissions, you must clearly demonstrate and quantify the reduction. Once emissions are quantified, you can monetize them using the information in Section 5.3 of FRA's BCA guidance.
Another outcome from an increase in both passenger and freight rail service is diversion from other modes. Many of the rail trips displace those that would otherwise be made by car, truck, or plane. Diversion to rail typically generates congestion, safety, and environmental benefits.
The other side of a benefit cost analysis is, you guessed it, costs. The cost of a project is the sum of the resources needed to realize the project's projected outcomes.
A thorough BCA should include all necessary costs, regardless of who bears them, to achieve the benefits. Common examples of costs are capital expenditures, operations and maintenance, and asset replacement costs.
Cost estimates in a BCA should use a life cycle approach. That is, the analysis should include the initial cost to acquire or construct an asset, as well as the cost needed to maintain and/or operate it.
Costs are generally incurred across a number of years. For costs incurred in the future, you should appropriately discount the cost to a base year. As we mentioned earlier, costs later in the analysis period are more heavily discounted.
Capital costs are the sum of money required to build a project and/or acquire necessary assets. Capital costs generally include all materials and labor, as well as costs associated with planning and design, environmental review, land acquisition, and transaction costs for securing financing.
In the early stages of project planning, some projects may have uncertainty with respect to capital cost expenditures. For example, in a region-wide planning effort, due to future funding uncertainty, you may not know exactly when you will be able to construct a certain portion of the project. In these cases, FRA advises you to use a reasonable estimate and to document all assumptions.
Operations and maintenance, or O&M costs, are those required on a continuing basis to support core railroad functions. You should include O&M costs that will be incurred throughout the entire analysis period. Common O&M cost categories include employee salaries and benefits, costs at stations such as ticket sales, utilities and maintenance, lease payments on rolling stock, railroad maintenance, and general and administrative costs.
It's important to consider the difference between your chosen analysis period and the useful life of the assets included in your BCA. Some railroad equipment or infrastructure will be useful for much longer than your analysis period.
Conversely, some equipment may not be designed to last for the duration of the analysis period. You may have to include some capital costs more than once. For example, if your analysis period is for 20 years, and your BCA includes a piece of equipment designed to only last 15 years, you should assume that the full cost of that equipment will be incurred again in year 15.
One way to account for assets still in use at the end of the analysis period is to net out the remaining value of the asset. This is called the residual value. Using the previous example, after 20 years, you still have 10 years of useful life remaining in the replacement equipment. Because you've used 5 years of the expected 15-year life of your equipment, its residual value is 2/3 of its value at the 20-year mark. Residual values are then discounted to their present value using the discount rate applied to year 20. You should be sure to describe the useful life assumptions that you use when expressing residual value.
Does your project benefit the users of your railroad and the public more than it costs in resources? The ultimate goal of quantifying and monetizing the benefits and costs of a project is to express the net benefits. In addition, it is common for a BCA to include a benefit-cost ratio as an additional metric to evaluate the proposed project.
Net benefits are the total estimated benefits of your project minus the total estimated costs of your project. A benefit-cost ratio is the estimated value of benefits divided by the costs. When the calculated net benefit is a positive value, it means that the benefits of your project outweigh the costs. This corresponds to a benefit-cost ratio greater than 1. A negative net benefit value means that the costs exceed the benefits. This corresponds to a benefit-cost ratio of less than 1. For projects with a negative net benefit, FRA expects you to provide a compelling argument to justify the cost.
That was a lot of information. Let's take a minute to review by going through a quick quiz. Question 1. Which of the following has been adjusted for inflation such that it has the same buying power in any given year? A. A nominal dollar. B. An imaginary dollar. C. A real dollar. D. A Canadian dollar.
The correct answer is C. Real dollars are adjusted for inflation. Nominal dollars have not been adjusted for inflation.
Question 2. True or false? Economic benefits include increased spending and job creation in the region.
False. It is important to differentiate between economic benefits and economic impacts. For BCAs, benefits refer to the outcomes that lead to societal improvements as a whole. Impacts, however, focus on regional changes, like spending and job creation, which fail to consider changes to the overall society.
Question 3. True or false? The analysis period of your BCA should only include the period over which you expect to incur costs.
False. The analysis period should include the period over which you will incur costs and accrue benefits. The recommended minimum analysis period is 20 years, but this can vary depending on your project. By completing a thorough benefit cost analysis, you will be able to clearly communicate to FRA the benefits your project will afford the users of your rail system and society at large. You'll also be able to monetize the costs involved. Estimating net benefits of your project improves policy decision-making and the planning process by clearly expressing the outcomes of proposed projects. FRA encourages BCAs for all types of rail projects.
For more information about benefit cost analysis, please review the web pages and contact information provided on your screen. Thank you.